All right, so here's our recording. Welcome again to Math 123, Section 04D, Tuesday night from 8 to 9 p.m. Eastern Time. And so our assignments, I want to make sure you know what they are. We are doing the web work, the orientation, web work 1 and 2, and then discussion board 1. Those are all due a week and a day from the class that we talk about it on. So that's all due next Wednesday. And then next Tuesday, we'll do section web work 3 and quiz 1, and that'll be due the following Wednesday. Okay. Yes, I will in the announcements. Okay, so I have a YouTube account. I think it's called John F. Ivy Tech or something like that. But I'll post a link to it so you can go back and review this video. I'll put it in the announcements. Okay. That's a great question. Thank you, Kinder, for asking and reminding me. All right. So let's try this. And you tell me, I mean, if we need to skip through this or if you have a question about it, you slow me down because it's going to be kind of fast and furious here to get through today's stuff. And the next week, slow down a tiny bit maybe. All right. So if you look in your book on page 4, there's a question here. It's just talking to you about general ideas about quantitative reasoning and how questions should be answered. So this first one says, students were asked to compare the enrollment at the Geary campus with the enrollment at the Fort Wayne campus. Here are some of their responses. Fort Wayne has a lot more. There's a difference of 4,264. There are 4,264 more students enrolled at Fort Wayne than there are at Geary. And then Fort Wayne's enrollment is almost 175% more than Gary's enrollment. And so while A is an opinion, B is true, C is true, D takes it a step further and actually takes this from being a subtraction problem into something more meaningful. And so if we think about this in a quantitative manner, D is the best answer. Even though B and C are correct, D is the best answer because it takes it a step further. And that's what we're going to learn how to do in this course, is take the problems from just doing an add, subtract, multiply, or divide problem, and we're going to take it a step further and interpret the meaning. We're going to think quantitatively rather than numerically. Well, I'm going to have to call Becky. I'm going to have to send her a text and tell her I don't like her answer. All right. Becky and I, we go back a long ways. We knew each other as high school teachers. But C is correct. But when we think quantitatively, we want to really get to D. All right. So number 3, students were asked to find the annual cost of Ivy Tech per taxpayer. The state of Indiana budgeted $240 million, and there are about 3 million taxpayers. So if we look at these answers and we go along, we're looking for cost per taxpayer. That means dollars per person. So let's see. This answer is a percentage, so we know that that's not even a valid answer. Let me look at D. Well, that's an opinion too, or it might not even be true. I don't know if it is or not. Letter C, that's dividing the wrong way. I think this is the taxpayers. So this is taxpayers per dollar. So that's divided in the wrong order. So it is going to be letter B because it's $240 million divided by 3 million people. And our answer should be the number of dollars per person. So it's, you have to look at the words in the problem to make sense of them too a lot of times. All right, so let's get into a little bit more of the math part of this. And again, make sure you watch the videos, read through your book. Don't just look at the sparse problems that we look at in class, okay? So this here is on page 11. So if you have your book in front of you, flip to page 11. And if you don't have a book yet, I think there's instructions in the syllabus on how to resolve that. And if you can't get it resolved, let me know as soon as possible. The book should be mailed to you as soon as you register. So if you just registered in the past day or two, then your book might not have gotten there yet. But if you've registered more than a few days ago, you've probably gotten your book already. And again, sometimes there's issues. You want to check your mailing address check the mailing address you have in your student information, because sometimes if you've moved since you've registered, or something happens like that, maybe you're young and you live with your parents still, and you use your parents' address on your registration, and now you moved and you're on campus and your address is different. It might have gone to your parents' house or something like that. Okay, so here in section 2, it says here a ratio is a comparison of the relative size of two quantities, and a unit price is a ratio of cost per one item, and it shows some examples of unit prices here. $9.99 for 18 cans is 56 cents a can. $12.50 for 24 cans is 52 cents a can. And it says based on the unit price of the two available options, which is the better buy? And so we use the unit price to make comparisons in this manner. So we're taking the price divided by the number of items. That's the ratio. So one ratio is 56 cents to one can. The other ratio is 52 cents to one can. And we're using the comparison of those two ratios to see which is better. And the better buy, of course, is which one? Yes. And so so you guys get an attendance grade, so I want to make sure you're clear on this too. So your attendance grade is based on not only you being here, but you participating. So you've got to participate. I'm checking participation in the first half and the second half. So either participating with your voice. So if you use your voice, make sure you say, "Hey, this is so and so." If you're in the chat, I can tell who's participating, so I mark that down. So to get the participation points, you've got to be active in the class. You can't just set it up and then walk away, okay? And I can actually tell if you're not on our screen. So if you're in here and you have a different screen up, I get a notification, so you can't get away with doing something else while the class is in session. Okay, and I see your note, Kelly. Okay. So if you send, okay. So Kelly had a question about WebWork question, and I'm trying to get it here, okay? So let me continue on, and I'll get to that in a little bit. So the 24 can pack is better because it's less money per can, right? All right. So ratios can be written with a colon, with the word to, with the word per, or as a fraction or as a decimal. And so those are all different ways to write a ratio. So number 7 here on page 13 says a recipe calls for 2 cups of milk for every 3 cups of pancake mix. And so let's take a look at these questions. What is the ratio of pancake mix to milk? So you've got to look at the question carefully and compare it to the information that's given. And so if we look at the information given, it gives us cups to pancake mix. And the question wants the pancake mix first. So our ratio is going to be 3 to 2. And then letter B here says, if the recipe feeds 4 people, how would you scale it up to feed 16? What would you do if this recipe feeds 4 people? How would you make it feed 16 people? And Kelsey, okay, I see all your answers. Multiply by 4. What are you going to multiply by 4? The 3 or the 2? Awesome. You guys are phenomenal this evening. You multiply both of the numbers by 4. You have to quadruple the milk and the pancake mix. So I guess the ratio would be 12 to 8. 12 cups of pancake mix to 8 cups of milk. So we can expand the ratios and we can reduce them too. So if we just had this ratio of 12 to 8 and we wanted to simplify it, we would write it as 3 to 2. All right, so then it says explain what happens to the units of measure in the examples above. So if we wrote this as a fraction, 12 cups to 8 cups, the unit of measure is cups. So we want to know what happens to those units. They actually reduce each other out, and there aren't any units in this case. So it's just 12 to 8. It's not 12 cups to 8 cups. It's just 12 to 8 mathematically. So the ratio is the same regardless of the units used. It doesn't matter what units we use here. But there might be a case where you have something like 3 weeks. Whoa, I don't know what just happened there. Let me try that again. You might have a situation where you have something that says 3 weeks to 5 days, or let's say, let me change that. Let's say 52 days. Now here we have a problem because the units aren't the same. So here, yes, in this example, the units canceled out because they're the same. So what we want to do is we want to make a comparison. We need to make sure these units are the same in this type of comparison. So I don't know, we could either convert the 52 days into weeks, or we could convert the 3 weeks into days. And let's change the weeks into days. So normally we change to the smaller unit. So 3 weeks is, there's 7 days in 1 week, so 21 days to 52 days. Now we can just write this as a fraction and reduce it, 21 to 52. I don't even know if we can reduce that. 13 times 4, 3 times 7. We can't even reduce that, but that's a comparison where we can actually compare the different time units by making the time units the same. Well, the reason the measurement cancels out is because it's really just like a fraction. Like if I had 21 over 28, 21 over 28 is really like 3 times 7 and 3 times 8. And since we have a 3 as a factor on the top, the numerator, and a 3 in the denominator, we reduce them out. So it's like 3 divided by 3 is a 1, so they go away. Cups divided by cups is 1, so they go away. I think that's the idea behind that. Sometimes the units might not cancel out. Like up here in this first example, here the units don't cancel out because it's dollars and cans, so those don't cancel out. All right, so interpreting ratios. It says here the local firehouse cooked 700 pieces of chicken for an estimated 240 people coming to their fundraiser. What is the ratio of chicken to people? And then it says use this in a meaningful sentence. I got to tell you, I had a student one time who was a firefighter, and she was like, well, there's no way they would only cook 780 pieces of chicken. She goes, it might be 1,780 pieces of chicken. And she's like, we at the firehouse, we love chicken. So that was one of my students I had a couple of semesters ago. It was pretty funny. But anyway, she says at the firehouse, it's way more than 780. But let's find this ratio. We want the ratio of chicken to people. So we can just write it 780 to 240. And what we're going to do is we want to reduce that. And it looks like in the chat I'm getting some reduced answers. Good. So the first thing I would do is I would divide them by 10 and make it 78 over 24. And then, because in order to make this meaningful, we want to make this in the simplest form that we can. And we can even make it a decimal, like it looks like Kaylee made it a decimal. That's a great idea because that we know what 3.25 pieces is, right? That's like it's like a half a chicken plus the wing, right? Something like that. So if we reduce this, we get 13. It looks like we get 13 to 4. I'm going with what you guys wrote. I didn't reduce it. I wrote it. So 13 to 4, which is 3.25. So we would write it. I guess there's a few ways we could say this. So if we were to write a meaningful sentence, we would say something like, the firehouse cooked 3.25 pieces of chicken per person. Or you could say they cooked 13 pieces for every 4 people. But 3.25 pieces per person would probably be the best. Because we can visualize that. I can visualize my son walking off with, 3.25 pieces of chicken. Okay, so we'd have a little bit in front here that said, the firehouse cooked 3.25 pieces of chicken per person. So that's what it means when it's saying to write it in a meaningful sentence. Okay, and that might be a struggle here in the beginning, but as we go along, that writing the meaningful sentence, it'll get easier and it'll make more sense. And we'll do more examples as we go along. Okay. So I want to stop first and ask, are there any questions so far with just the introduction of a ratio that I haven't answered? All right, you're welcome, Kayla. After 25 or so years of teaching and thousands of students over those 25 years, you get pretty good at names. Now there's some I can't say. I promise you, it's Justina's last name. So, all right, Kiara, what is your question? So, Kiara, did you have a question? Back my screen up like this. Oh, did I screw that up? Oh my gosh. This should have said 24. I'm sorry about that. Thank you for calling out my math there. I'm allowed one mistake per year, so that's it. Okay. So, that master's degree in math was really difficult to get. And I can do all the hard math, and sometimes my simple algebra gets me. So I am sorry. And I will try not to let that happen again. All right. Very good. Yes, I can do all the high calculus and calc 3 and 4 and differential equations, but I have a hard time multiplying. All right. So let's look now at these ratios are either part to part or part to whole. And this is going to give us some meaning in the ratios. So a part-to-part ratio, it says here, compares two things based upon their differences. They're both parts of the same big group. And then part-to-whole compares one thing to the entire lot or to the whole group. So let's say I'm teaching a class of second graders and I have 11 boys and 14 girls in the class. The ratio of boys to girls would be part to part because each group is part of the whole class. So that ratio would be 11 to 14 boys to girls. But if I wanted to write a part to whole ratio, since there are 25 kids in the class, it would be, if I did what's the ratio of boys to the class, that would be part to whole, and I could write it as 11 to 25. And then I could even make that a percentage. So when you do part to whole ratios, you can write those as percent. So let me write that again here. If I have 11 to 14, this is boys to girls, it would be 11 to 25. This would be the boys in the class. And I could write that, I could say 44% of the class are boys. 11 divided by 25 is 0.44. And so 44% of the students are boys, I could say. Or I could say 56% of the students are girls, 14 to 25. So 56% are girls and 44% are boys. So we could do part to whole and make that a percentage. So that would be giving this a quantitative piece, so thinking quantitatively, bringing it more than just writing the ratio. So on page 17, there's a couple of charts, bar graphs actually, and it says the information from the table was used to create the following bar graphs. So let's flip over to page 17. And we have these two bar graphs, and one of them shows unemployment by educational attainment. And it says less than a high school diploma, high school graduate or equivalent, some college, associate, bachelor's, advanced degree. The next one says the unemployment rate by educational attainment, and it has percentages on the side. So the first one, the top one, has numbers on the side, and the bottom one has percentages on the side. And it says the unemployment rate for less than high school is 8%. The unemployment rate for high school graduate is about 5.5%. And these are all from that table on the previous page. And then some college is 5%, associate is like 3.9%. And then the other two. And it wants us to compare the two graphs and asks us, why do the bars follow different patterns? And so again, the top one is a number of people. The bottom one is percentages within each group. So the top graph shows us how many unemployed there were. So let's see. So the less than a high school diploma, it looks like, I don't know how many people have it. 873. So 873 unemployed people. And then on the chart, it says there are 10,000 people in that group. So the percent is the number of unemployed people in that group divided by the number of people in that group. And so the total number of people in the group is significant in determining that percentage, because look at this, the high school graduate, there's a lot more unemployed high school graduates than there are less than high school, but the percentage is lower, and that's because the number of the group is so much bigger. So in comparing those, we're comparing, we're saying, okay, compare, well, the bars in the top represent numbers of people, the bars in the bottom represent the percent in that particular category that are unemployed. So the number of unemployed people divided by the number of unemployed people, or the number of total people in that category. And that's why they follow different patterns. They're representing different pieces of information. Well, I see your question, Roberta, there, your statement. So the top is not actually a ratio. The top is just a straight number. Here's how many people were unemployed. The bottom graph is a ratio. It's a part to whole in that specific category. And that's what we can write it as, a percent. So good observations. All right, so a lot of your work will be on your homework and your exams and your quizzes will be dealing with age dependency ratios. So I want to make sure we get some time in on this. So age dependency ratios, there's actually 3 of them. All right, I'm so thankful I have a cough button. My my voice is crazy right now. So that's why I'm fading in and out. My voice is a mess. And I might click my mute button so you don't hear me coughing over here, okay? So I'm going to try and work it out. I'm going to get a drink of water. Give me just a second. All right. So yeah, it's actually, I had a difficult issue. I had to testify in court today, and my voice was a mess, and I was like, the microphone's right in front of my face, and I'm like trying to cough and not be coughing and everything, and I could not clear my throat, and so I sounded like the Godfather the entire time I was talking today. It was crazy. So I'm going to try not to talk like the Godfather the rest of the class tonight, okay? All right. So here goes. So age dependency ratios, there's really 3 that we're concerned with. There's a child dependency ratio, there's an old age dependency ratio, and there's an age dependency ratio. So let me just give you an overview. So the child dependency ratio is it's a ratio of the under 15-year-old people to the working people, which we consider 15 to 64 years old. So the child dependency ratio is children to the workers. The old age dependency ratio is the older people, 65 and older, to the workers. Okay, so those are part-to-part ratios. And then the age dependency ratio is the total of the children and the older people together compared to the working people. All right. And so when we think about dependency ratios, let's say a child dependency ratio was 0.2 to 1. So there's 0.2. Let's say it was 0.2. So it would be 20 hundredths if we say that number correctly. So the decimal 0.2 is 2/10 or 20 hundredths. And so if that was the dependency ratio, we'd say each worker has to support 0.2 children besides themselves. Or we could say this is 2/10. That's how we say that name. That's how we say that number actually correctly. 2/10 is a way to say it. We could say that it takes 10 workers to support 2 dependents besides supporting themselves. That's what that means. And so let's look at number 4. Number 4 says calculate the ratio of under 15-year-olds to the total population. So we've already got these broken into the categories here. So the under 15s is 62,155. Now I want you to notice that it's actually 62,155,000 because the numbers are given in thousands, okay? And then over the total, 306,108,000. And I want you to note that we don't have to put these 3 zeros in our ratio, okay? Because if we divide them out or divide each one by 1,000, they go away anyway. So 62,155 divided by 306,108. We want the decimal. So when we're doing these age dependency ratios, we want the decimal. So we want to take out a couple of decimal places. So when I divide this, let's see what I get. Let's see, I got 0.203. All right, so when we do these ratios, take them out a couple of decimal places, maybe 3 or 4, so that you can do part B, interpret the meaning, okay? So now the first thing we ask is this ratio part to part or part to whole? What do you think? 14-year-olds to the whole population. Obviously, right, it's part to whole because we're doing it to the total population. So since it's part to whole, we can write this as a percent. So to change the decimal to a percent, we move the decimal 2 places to the right, and it's 20.3%. And so for a meaningful sentence, we could say, I'm going to try and write this fast, 20.3% of the population Oh yeah, you guys are awesome. It's way easier to type it in the chat box than it is to put on the screen, right? Is under 15 years of age. So now remember earlier we looked at Becky's answer and someone said, well, Becky said it's letter B or letter C and I said it's letter D, right? Well, see why? Because we can take that and we can give it more meaning. And that's why I'm going to have to send Becky a text when I'm done here. All right. So let's see. Becky and I used to teach at a school and our doors faced each other. So when I walked out of my room, I could walk right into her room. Same with her. So we've known each other for a long time. So I can joke with Becky. So number 5 here says, now this is going to get us into the specific age dependency ratio. So the child dependency ratio, dividing the under 15 by the 16 to 54. So the children divided by the workers, basically. Is it part to part or part to whole? And thank you for your participation. That is part to part. Awesome, guys. Part to part, express it as a decimal round to the thousandths place. So if we're going to round this to the thousandths place, I have to get the numbers here real quick. 62,155 divided by 204,775. The thousandths place, so how many decimal places is that? It is 3 decimals, so tenths, hundredths, thousandths. So 3 decimal places. Let's see, 0.30. All right, so let's look at these numbers here. Let me put it in my calculator again. Calculator doesn't want to work. All right, so let me pop that in the calculator. 62,155 divided by 204,775. I get this number. I get 0.303528. And since we're looking at the thousandths place, we have to look to the right of it to decide whether this 3 stays the same or goes up. And so since this number is 5 or greater, our rounding place goes up, so it would be 0.304. And then it says, think about what the numerator and denominator represent. Write a meaningful sentence for all of this. And so my meaningful sentence that I wrote says, there are 0.304 children for every 15 to 64-year-old to support. Or you can say there are about 30 children for every 100 15 to 64-year-olds to support. So there are 0.304 children, that's an L, for every 15 to 64-year-old to support. And that's in addition to themselves. Okay. We don't want to say there are we want to take it out to the 0.304 because, if we expand this, it's 304 for every 1,000. So you could say 304 children for every 1,000. Since we run it to the thousandths place, we still want to carry that through our answers. All right, so there are 3 to 4 children for every 1,000 workers to support besides themselves, or there are 3 for every 10, or 30 for every 100, or 0.304 for every 1. And it says, how is this different than what was calculated number 4? Well, number 4 was a part to whole, right? It was a percent. We could do a percent. On this one, we can't do a percent. This one is just talking about the ratio of children to workers. So number 6 is the old age dependency ratio. And let's see, calculate the old age dependency ratio and write what it means. So the old age dependency ratio, now this is the 65 and older's 39,178 to that 204 775. And when we divide that, it looks like you guys are getting 0.191. Perfect. You should get 0.191. So this is the old age dependence. This is, we would say there are what, 0.191 old age dependents for every worker, or we could say there are about 19 old age dependents. So here's another way to write this besides what I did in the last example. There are about 19 old age dependents for every 100 workers. And so each worker needs to support 0.191 old age person besides themselves. Or every 100 workers, it takes 100 workers to support 19 old age dependents. Or 191 for every 1,000, like Kendra says. Perfect. So let's wrap this up. The age dependency ratio says is calculated by dividing the population under 15 and over 65 by the middle group. And we could do that. There's 2 ways we could do this. We could add the 2 populations up, the under 15 and the 65 and older. So can somebody add those up for us? The under 15 and the 65 and older. 101, 333. Okay. So how many people were age dependents? 101. Now this question, you need to answer this one correctly. 101, 333 is not the answer to part A. It's close. How many people were considered age dependents in 2011? It's not 101,333. It's, thank you, it's 101,333,000. That's the actual correct. Estefani, thank you so much. Awesome job. So that's how many age dependents there were. Okay. So it says calculate the ratio. So we're going to do the 101,333 divided by the 204. So let me write this down. 101,333 divided by 204,775. And we get 0.495. And I want you to notice something. See if you can make some sense out of that 495. So that means, that's about half, isn't it? You could say, there's about, it takes about 2 workers to support every one independent, excuse me, let me try that again. It's the first day with my new tongue, so forgive me. It takes 2 workers to support every one dependent, besides supporting themselves, because the ratio is a half, basically 1 to 2. So this 495, we could have gotten that a different way besides what we just did right here. There's another way we could have done that. Does anybody see how? All right, so Kelly, that's a good way to write this meaningful sentence. But is there another way to get the 495 than to calculate it like we just did right there? Awesome, Kendra. If you take a look at the 2 age dependency ratios we already found, we found the child dependency ratio and we found the old age dependency ratio. And if you add those up, it gives us the age dependency ratio. So all we did, so we can either add the numbers first and divide by the middle group, or we could find the two ratios and add them up to get the age dependency ratio. So my philosophy on this is, you already found these two, so just add them up to get your next, you already found the child dependency ratio and the old age dependency ratio, just add them together to get the total age dependency ratio, instead of doing all, figuring out all these numbers and then dividing again. Make it easy on yourself. All right, so let me just check my attendance one last time. I am looking for Kristen Green. Did Kristen Green come in? I don't see her name yet. Antoinette, Christina, or Miley, or Carly. Oh, all right. So let me stop the recording